this computer. So, recording is on. Feels weird. I usually was the master of Zoom a couple of months ago, sitting 10 hours straight in front of it. So therefore, it feels a little bit weird after a very nice period in front of actual people. So we are back to the screen.
This is the screen.
Perfect.
This is the screen, and this is the team, as you already explained.
So perfect, precisely. And now we will jump into the different, maybe you can go into full screen mode.
Full screen mode, full screen mode.
Or presentation mode.
Donk. Does work?
Perfect, looks good. Shall I read out loud the question? So we got a question from Jeff. The facade of the National Grand Theatre of China appears in an elliptical shape, like a dome, which is supported by steel skeletons. The outer layer of the facade skin consists of titanium composite panels and insulated laminated glass, above which the line of weather protection lies. The middle layer of insulation exists between glass panels and beneath the cavity underneath the titanium skin. The inner layer of damp control is realized by inner glass panels and membranes beneath titanium parts insulation. That seems to be one of the many different projects the students have joined itself. Is there a question behind, or do we talk about the construction in general? There's a question. So I'm not sure whether the insulation line should be connected through the gutter part, since I do not reckon the gutter material is thermal protective. Thus, spots like the gutter part here are actually thermal bridges. Thank you in advance for your replies. So
yeah, they're thermal bridges. That's simple.
Yeah, there are thermal bridges, and especially can you go back one picture earlier? We also see a picture here, and that's a kind of like a tricky part of that building. I've been there, visited it, and there is a little sea that is around the building. The entrance actually is underneath via a tunnel. So therefore, the building is actually, the facade is very close to the water. And the facade is, there is a thermal bridge sort of. So there might be a short insulation line, but in this case, it is also penetrated by air and from underneath. So therefore, I think that's what you have to accomplish. I noticed that there is close to the floor detail, whenever you approach the facade, a roaster. That means that they have a heating or ventilation, at least, to make sure of any condensation that may appear close to the facade is blown away or heated against. That's
a complex project detail.
Yeah.
The main question here, yes, you're going to have thermal bridges. That's simple.
Yeah, you have to somehow accept that, and especially knowing that, you have to be careful that you are able to check them every now and then.
Yep.
I have no problems if I know exactly, according to my isothermic calculations, where condensation in a few days may appear, especially when there are visible surfaces that are in sight. Then I can check every now and then. I can also ask the person over there that, hey, there might be a rare occasions in winter and whatsoever, that check there. If condensation appears there, no problem. Problem is if you have it appearing in a hidden layer, a layer that shouldn't get moist, that you can't check. And if water accumulates even over the summer when it should be dried out, then you have a problem that will also ruin structure and so on, because you can't see and you don't know if you're on a ticking bomb. Or, isn't it, Oli?
Yeah.
We have Tatjana now. Hi, Tatjana. She also joins us right now.
And Tatjana, exact. That's what I wanted to say.
We have already started the little session.
Thanks for preparing these questions.
Thank you very much.
Precisely.
Marcel is videotaping it, and I handle the PowerPoint, and I go to the next question.
Precisely.
Thank you very much, Ulrich. Thank
Super.
you very much.
Bang, here we go.
So, Arezzo.
Okay.
That is, that is an interesting facade. Completed in June 2012, the 145-meter towers Mashrabia shading system was developed by the computational design team of AEDAS. Screen operates at a curtain wall, sitting 2 meters aside the building. Screens will close. Most likely, a couple of people already know that building. Such a screen will be reducing solar gain by more than 50% and reduce the building's need for energy draining air conditions. Plus, the shade's ability to filter the light has allowed the architects to be more selective in glass finished. Sounds a little bit like the advertisement text from the building, but let's first have a look at the question.
Well,
I know this building.
Hits exactly the point.
I know this building, and it is one of the iconic buildings in the United Arab Emirates. The facade is composed of a dynamic and parametric elements. I just have one question. Is there any strategy, maintenance and cleaning of those parametric elements? Do you have the connection detail of those sun shading elements with the substructure behind and with each other? That's a good answer. Uli.
We actually should ask him if he knows the building, if it's still functioning full scale.
Precisely.
When we saw the details and when we were talking to the engineer, the head behind, we had exactly the same question, and he was answering it. Yeah, well, they tested it in the sun, in a sandstorm, and it still continued to work. But when I see all these moving parts in that harsh environment, that's really something which for sure will request at least a constant maintenance to secure that all these nice details are still functioning.
Yeah.
They for sure have a strategy for it, but it also has to be followed. It's just expensive, complex details in a harsh climate.
Yeah, and we also have to be aware of the brief. So we have this building within our classes in the facade engineering in Delft, but we also, I see this 5 times within every Buckylab semester. And I would like to see the brief of that. So under which circumstances is that facade made? And budget in this case was not an issue.
Yeah.
And this is also set up as a project that has to be representative, iconic, and therefore money, especially running costs, were not a consideration.
If say being iconic was part of the brief, that worked out well.
Yeah, precisely. So therefore, there's also iconic buildings in that country that has integrated wind turbines, which are which have to be powered by electrical power to rotate because they are in a position where there's no wind. So therefore, they have a check mark on the iconic view, but they won't be able to serve any sustainability purposes because there's not enough wind over there to be harvested. It's just a big gesture. So therefore, I highly recommend to consider such intricate moving elements in harsh, stormy conditions. We even had already 15 years ago Sauerbruch and Hatten, Berlin, the GSW facade, which was a double cavity facade, which had nice pink, green, bluish vertical lamellas within the cavity of the facade. The facade contractor got bankrupt after he had to service these elements in the hot upstream air for over a year to be greased and oiled regularly because the hot air blew the grease out of the hinges and the elements start to be stuck or making noises because they were not well oiled. So even in a very controlled
environment
cavity and in Germany not so extreme, it's difficult to maintain. You always have to be aware that you have one crew over there who cleans up all the hinges and so on. So therefore, a wonderful project, but for me, one of the examples in order to show that this is not according to a low maintenance schedule and low costs.
Let's say resistance of this building is a different story. So if say budget keeps not being an issue, this may be a good solution. And yes, it makes sense to have an adaptive shading system in this environment, no question. But yeah, you have to secure that this is possible.
Yeah.
So when you're active as a facade designer, facade engineer, you may need to understand if your client is really capable to do something like this. If you would build this for, say, public authority, which every now and then are very, very, say, down with money, this would be a wrong decision.
Yeah. So always be careful if you have the budget or so to look after that. That's no problem at all.
So I'm clear with the replying in this question. You said that it will be like very often maintenance because of the conditions, and more likely will be like a crew who is doing it, this maintenance of the building, right?
Yeah.
Yeah.
I would directly put a container there where the three guys with a broom, a vacuum cleaner, and an oil can lives, because they have to live there unless the building will stop be using.
Yeah, there are other buildings which are dealing with that. Eiffel Tower needs to be painted by a group of 7 every day.
Yeah.
So if this is and the iconic part, that's done. A tick for the next one, just to somehow keep the speed, because there's so many questions.
Perfect.
Well, that's the same project. This one, tiny house, United States, Buffalo.
Yeah. The construction is very common for our region and consists of 2x6 stud walls, load bearing with a 1/2-inch exterior sheeting and 1/2-inch gypsum board interior. The line of defense for air and water are clapboards, rain and snow, a vapor permeable air and water barrier, 6 mil poly. This I think is an insulation for vapor barrier, inside surface for our climate. And the question is, I've always assumed that this kind of cladding was also made out of wood. How do you attach it to the wood studs? Isn't there a chance to rip the water barrier? So I have to figure out how this works. So this is in principle very common American balloon framing.
Same here. Well, the outer cladding, that's what we talk about, don't we?
Yes.
And if that outer cladding is fixed by nails, true.
Yeah, my personal experience is also with other facades we have, that shows if you once shoot a nail or any kind of staples or rivets through a film or a foil, in this case the vapor barrier, it is still vapor tight unless you take it out again. So if you nail it to, or you screw it to, and you don't take them out and in again, it's still fine. But the moment you take it out and in, you may already gain with the leakage. But you also have to be aware that if you hit the vapor barrier on a stud, the stud is like in this case 2x6, so it's 2 inches. Even if you put the screw in the middle, it will press the cladding will press the vapor barrier within the 2 hard elements. So if there's even a little hole, it will be almost covered because of the pressure of the 2 members. So therefore, it is not that problematic. The bigger problem is if you miss a stud, you shoot a hole through your cladding, through the barrier, into the insulation, you take it out, and then you have a hole, and then you will create a leakage. But it's not that it is a leakage as in a bag of water or a water balloon that it directly runs out. We're talking about a vapor barrier, means that it's a pressure from the inside to the outside, it's already behind the cladding, so therefore, to a certain amount, it's forgivable. But you should be able to execute this thoroughly, because the more holes you add to this layer, the more difficult it gets.
Yeah, it's true.
And if we talk about, this is, say, Marcel, when we talk about new buildings.
Yeah, precisely.
If you talk about, say, historical buildings, older buildings, windows of the 60s, 70s, the window itself is already leaking a lot.
Yeah.
So the air pressure will be a lot less. And in that respect, this is more forgivable, which also brings us to the point. The more, say, perfect we build our buildings, the more perfect the details need to be.
Yeah, and there's a reason why we nowadays use the tape to also cover every seam of the vapor barrier. in order to make a 100% airtight or vapor-tight barrier. Airtight is something different than vapor-tight, so be aware of that. For instance, a chips bag, that is 100% moisture-proof. This is 6 or 8 layers of plastics and other materials stacked on top of each other. So chips bags is almost NASA stuff, in order to make sure that whenever you open your chips bag, that it's still crunchy, because if there's a single drop of water coming in, your chips will not be crunchy anymore and you will never buy them again. So therefore, it's high tech used in chips bags right now, even if it's so thin. In the houses, an older house have many leakages that will also ventilate away humidity problems. The newer it is, totally right. And if you want to make sure, if you have a new building, make a blower door test and run around with a thermal camera. You can unveil leakages easily by visually inspecting them through the thermal camera. Sometimes, especially if it's in between the layers, you can't localize them directly, but they already give you an idea if there is something behind luring for problems.
So in case that we need to repair a leakage in one of the malls, what should be the best strategy to do so? Remove completely of one of the panels will be, or how do you suggest will be the best strategy to
the problem with shingles is almost, if you do it correctly, you start on top and you bring them down because they have an overlap. The experts can also rip apart a couple of few pieces and make some adjustments in order to repair also a hole in the middle of the sheeting. And then if you find a hole in the barrier, just tape it with the standard tape. That's already fine. And
but Marcel, if I take off some shingles and I nail them again, I punch new holes.
But
taking off some actually means you take off the whole part and then you cover it again with a barrier. Yeah,
but as I mentioned, if you shoot a nail through it into the stud, everything is sealed again. It's a little, it's whenever you put it into, it's fine. Don't take them out and put again in. So therefore,
that's what I mean. Yeah? When you take them out, the whole thing actually gets difficult.
Yeah, precisely. Then you should also replace the vapor barrier of that part you opened.
Yeah, and then it gets larger and larger and larger. Better don't.
Yeah, precisely. At a certain point,
I go for the next.
Precisely. Ruben, the facade system is connected to the structural system by the prefab walls and the hollow core deck. The question is it a panel system which connects at top and bottom? Are there movement allowances in the top and bottom connections? So we have to zoom in a little bit more to see the detail right now. I understand that this is a concrete structure. Yeah, there is a vertical concrete basement wall, and then there is a prefab element. That's the darker part in the center of the detail. And then there's a hollow slab horizontal. In general, you have to allow for tolerances and movements in these structures, otherwise you won't be able to build them. We see with the black line coming from in between the load-bearing faces and the insulation layer that comes up. I think that's the vertical water barrier that goes on top of the prefab concrete element, the sort of beam-ish, and stops there. There is movement allowance, and from the inside, the detail is not clear enough. In general, you always have to deal with movements of prefab elements. So therefore,
but do I read it right that these are prefab elements which are then combined in this square part in the middle? This square part in the middle, this part, is this then on-site concrete?
Yeah, no, this looks more like a hatch from a prefab element, isn't it?
Hard to say.
Hard to say. I would say this is a prefab beam.
Is the person who did send this in, is it in the chat?
Maybe.
In the call?
Can you zoom out? Who was asking that question? Now I have a zoomed in version.
Ruben Cavallo.
Ruben. No, we can't see him. He's not. No. We have to leave that a little bit open, but
I come back to this. I come back to this in a second. Give me a moment. Freigabe. Pang. Bang. Now you should see it again.
Yeah.
You see it? Good.
It remains the same. No, I would say I have to pass. In general, if you work on or with prefab elements, you have to make sure that they are able to move somehow. It's also part of the foundation that still moves a little bit, especially here, seems to be close to the water or is close to the water. You always have to make sure that the details are not vulnerable against any movements, and especially if it's here against water and so on. So therefore, there might be some movement, and the details have to take care of that.
All right, let's go for the next.
Not the best answer. So can you go up to perfect full screen? Femi is asking, describes a building as part of a primary structure as well as shell of the building. The facade is made from load-bearing concrete wall. There are two types of facade systems in the building: a external thermal insulation system on a concrete wall. So that's what's been in Germany called a facade, ein Wärmedämmverbundsystem, and the ventilated rain screen cladding facade system, mostly on protruding external walls. So, and the question is, to my understanding, the difference between these two types is what type 2 have a cladding whilst type 1 does not. And I'm not sure if it is only a reason of rainproofing, whether there's a balcony above or not, or rather if it's a choice of facade expression in terms of using different materials.
No.
Project choose to have the insulation layer on the outside of the load-bearing layer, which might prevent some problems of cold bridge and ease the installation of furniture inside. I like how design takes those into consideration in an early stage.
Shall I zoom into this as well, or are we going to use this this setup?
Yeah, I think these are the two main facade types you have for a punctured wall design, let's say. Maybe you zoom in a little bit more into the picture and section element.
So let's take this a bit bigger. You should see it.
Yeah, super.
And so what we see, and oops, sorry, wrong button.
You're also out of the game a little bit, huh?
Yeah, obviously. Kommentieren da.
Yeah.
So what we see is this is a main structure.
Yeah.
And that's main structure on both the same.
Yeah.
Exactly.
And then there's window next to it. And then we see there's insulation at the lower of this picture, which is then outside. Yeah. And there's either the one which is the bottom one, the type 1, which is polystyrol, polyurethane, rock wool-like material, which is actually glued to the concrete and secured with some screws, which is then closed at the outer layer with a plaster, which is a cheap, simple, efficient solution, which has the downside: if there's any leakage at the outside plaster layer, it may find its way into the system, and it actually sounds quite hollow. So the building itself feels a bit flimsy.
Yeah, it's the cheapest insulating wall system for punctured walls you can choose from. If you choose for an insulating one, massive one is of course even cheaper if you're building in climates which doesn't need any insulation, which is even against hotter climates recommended. But this is the cheapest solution. On the long run, it's also a question how to get rid of it if the building is not needed anymore.
That's a different course.
Precisely.
And that's then facade type 2, which has an insulation layer, which we see here as well, and then it has an outer cladding. Yeah. And this outer cladding then allows you to come with what kind of cladding you ever want, the timber shingles or some kind of
Trespa, high pressure laminate, reinforced concrete elements, stone even, for instance, slate or something like that.
We actually did the Detmold project with that one.
Yeah,
Daniel Arzman was giving his.
Yeah, precisely.
That's exactly this cladding.
Precisely.
Go on.
The reddish huge tiles on the facade one was the type 2 facade cladding.
And then this cladding is in a distance to the insulation itself, which creates this cavity. And this cavity has the main feature that if there's some leakage in the system, water finds its way into it, it's drained to the bottom and then out of the building. So it delivers a kind of additional security as a cladding system. So totally different types of construction. The first one, type 1, being, well, quite cheap as a setting, but then having the limitations by recycling and also feeling flimsy, while the type 2 creates hopefully the same kind of insulation, has this cavity, and by that creates a kind of additional security for the building. It's a kind of a raincoat, which is the outer cladding, which covers it.
What's interesting from the building physics point of view, that's what we also described, I think, within the MOOC, is that the building physics in type 2 facades, ventilated cladding, already ends in front of the insulation layer. The cavity itself is already communicating with the outdoor climate, and the rain shield in front is just a mechanical barrier, like a rain jacket, but ventilated. So everything that happens within that is already done after the insulation, while the exterior system with the for type 2, with the type 1 facade, that's the outer layer, is also directly connected to the insulation. Most likely they will use insulation that is styrofoam or something like that, that is already resistant against moisture in case of punctures. If it's out of a mineral wool or something like that, then you have to make sure that your raincoat, the outer plaster layer, is really not having any issues with leakages.
And how do you see this system now? Do you think it's a typical solution for this kind of weather conditions in Europe?
Yeah.
And is it effective, even though it's cheap, but still effective? Or
no, it's very effective. And I also have to say that the grand architects of this world who wants to play with surfaces and holes in it would prefer the type 1, because you can make seamless surfaces in any color, and then having the hole punched into it, while having type 2 is the more expensive one. You also have to think about the formats and the gaps, because there is elements visible. You have to deal with the connections. It's either hidden behind under the substructure or with visible screws. We have shown in Detmold at the university building, the red one with Daniel Arztmann in the MOOC, that there is visible connections in there, in this case rivets, even with colored heads. After 3-4 meters you won't see them anymore, but we often hear complaints from the architects that they don't like that, because you will see these rivets also create some shades and whatsoever, that they don't like that. So, but both are fine, but there's also a price difference, 30-40% more, I would say, at least, for type 2 ventilated claddings against the very simple one underneath type 1, even not more.
It goes on, the same project, same person. Second question: I could see a rain screen facade system for limited area in building skin. Any particular reason to come up with this design idea? We often design and install rain screen systems, ventilated facades, as we described it, to reduce HVAC load for the building base on energy analyzers. Any specific reason with this change of insulation type thickness, difference between the types of facade systems of these buildings? Well, I wouldn't expect to have different sizes of insulation with a rain screen and the EDIT system. No. I would actually expect the same dimension for insulation, because insulation has to do the U value to do the insulation. And then the cladding system with a cavity is just a 5-6 centimeter thicker, which may cause us a reason of arguing to not go for this, because you try to reduce wall dimension to increase floor space, if this is an argument. But I'm not aware of that argument to install rain screen systems to reduce HVAC loads. Well,
no. In principle, with both systems, you are able to apply whatever insulation value you are aiming for or is necessary for the building code within the different countries. You can either also choose, if you don't have the space for a higher value insulation, to reduce thickness, but both will perform the same in the insulation value. One or the other may have an advantage according to other requirements you may have. If you ever think of changing the layout of the facade, having an extension and so on, a ventilated rain screen facade in this case might be preferable because it's easier to take apart and change and whatsoever, while the plaster layer on the type 1 facade is almost kind of like, yeah, you will see if you have to cut through and change and do extensions of the building. So therefore might also be a factor, but this stuff is cheap and they will also figure out how to fix it in case you want to change something. But yeah, it's
interesting that he's arguing like this. Let's say in his environment, they argue that the ventilated system actually reduces HVAC loads.
Yeah, no, but in general, insulation does that for both systems, and you should consider also in very hot climates having a active insulation against the summer loads. That will also keep your buildings cold in the hot summers. So therefore, both systems will work the same.
Yeah, well, if you really, well, there's building physically speaking, there may be an aspect of having this additional layer shading the inner one, and then having 2 layers where, say, the vertical draft of the air appears in the cavity and at the outside, which is the same with the outside draft on the surface. But I don't expect that to be such a high impact. It's
no, but as I mentioned, usually for the U value calculations, the building physics stops at the front of the layer. So therefore,
But when you really dig into the Glaser diagram, for example, they find additional. That's well. I'm impressed about this argument.
Often it's a budget choice.
I always said yes, but maybe also the sun shading based on the location as well, because now you see they have sort of balcony thinking. Maybe that is also something that make the decision, help the decision-making process of the facade. Okay, still going a little bit this before we go to the next one. I have a question in the chat from
okay.
Let's do the chat question directly now. I saw it because it fits here, and then go
perfect. So Kaman asked, may I ask what are your take on those retrofit projects going on to clad historical buildings with insulation? Have there been pioneering alternatives? And would you mind sharing with us a brief update of your current research focus? So the first one, I think it's easy to answer. There is, of course, a huge trend that we've seen with these facade insulation layers, the type 1 facade that is shown here. We have seen that in Germany and all over Europe, extensively used. There's huge companies. It's also the type of the painters are right now doing this as retrofitting and refurbishing and increasing the value. They're also supported by local funding systems in order to insulate your house, reducing energy or whatsoever. But nowadays, especially within the TU Delft, we're at the forefront of circularity, thinking about which materials you use right now and which constructions in order to reduce the waste at the end of the lifetime. And this facades becomes always a huge problem. We hear from many voices, especially here in the Netherlands, saying, oh, the Germans use these facades for over 30 years. They are smart. They will come up with a solution. Honestly, up to now, even the Germans don't know where to end up with this. They end up as landfill and chemical waste. So therefore, it is a question if everything you have to protect from the older days can be easily cladded with a layer of polystyrene and plaster. Actually, you shouldn't. And that is already glimpsing in a little bit into our research focus, which is plenty of. I honestly can't answer that in one sentence. Highly recommend facadeworld.org or .com. Facadeworld.com. That is our link. We can type it in the chat. That is our research overview network site where Uli, being busy from Darmstadt and Delft, we from Delft, but also our friends and colleagues from all over the world share what we do. And our research goes in right now circularity aspects. So we have colleagues who think about how to overcome this sort of facades for the future that can be brought back to its original materials. but Uli is also on the forefront of additive manufacturing, for instance, how to print glass, stone, concrete, any kind of material you can imagine by 3D printing machines, for instance. We have a huge research also in refurbishment strategies for either office or residential buildings. We have now also a focus into human-centered, comfort-related facade systems. So there's a plethora. Each of our colleagues in total is busy with a different specific topic. And there is a couple of main directions, if that answers the question.
Great. Thank you, Marcel.
Yeah.
We can go maybe to the next one.
I go to the next. Yeah, I go to the next.
Precisely.
Here we go.
Chat, I already shared the link to the Facade World, so you can also check it out.
Yeah, Kaman already thanks. So therefore, yeah, check Facade World. You will find a couple of things we are right now busy with. So there's a question. I'd like the monolithic look of the building and the undulating vertical fins. I'm curious how thick a perforated metal like this should be designed to withstand wind load, especially on the high-rise buildings. Thank you in advance. Okay.
This is Saleva.
Precisely. Yeah, this is the building we have shown in northern Italy, Saleva. It's almost the same sort of thing. Yeah. The trick is within the geometry. If you have just a punctured piece of metal sheet, it won't be thick enough in order to withstand the wind loads that may be introduced by the height of the building. So therefore, we talk about 2, 3, 4 millimeters of aluminium. Yeah. At a certain point, we come in a relation of the distance between the substructure till which point the bare metal can span. But usually we will bend over the edges, create a U-shaped panel that is able and capable of withstanding the wind forces by its geometry itself. And then we can use thinner materials again, because the stiffness comes within the geometry you bend. So therefore, totally depends on the wind load of your building. We would highly recommend, if you plan such a building, that you are aware of the preliminary wind directions and the strengths of that wind that is facing these buildings. Often we also see with bigger high-rise projects also the aid of a wind consultant. We also had high-rise towers which were researched in wind testing facilities in order to see, especially at the top of the buildings, how uplifting winds may be a problem by creating extra forces in directions you haven't actually anticipated. But here the trick is it has to be not only a single sheet, but it has to be bent over and set in a way that it is, from its geometry, also withstanding.
That's what I mean with the drawings I did on
Precisely.
The top one is actually the cold band sheet metal, which then by this creates geometry, which creates the height you need for structure, versus the bottom one, the square block, which would be, say, a solid piece of metal, which you never would do.
No, precisely.
You remember that sample from Paris, which is hanging at Tillmann's office? Yeah. That's an aluminium facade, 3 meter high. It's
it's Jean Prouvé.
Yeah, but it's a 2 centimeter solid aluminium. You never ever would do this again now.
Yeah, it's a cast aluminium panel, 2 centimeters thick with a little border in the middle. This is amazing. Whoever jumps into our office is amazed by looking at it, and we always invite everyone to knock on it, because this is unbelievable. Nowadays, impossible to think about.
Exact. Well, let's go to the next question.
I like this question very much. Yeah. And I think the Saleva building is a very good project to look at.
Yeah.
Stefania, I will shorten this a little bit from the point of view of facade soft combination. The whole system is a non-load bearing, so it's necessary to fix the main structure. It's placed in position, and finally, not yet shown in the picture, the beams and glazing of the second skin are installed. In any case, the elements of phase 1 and 3 can be classified as a post and beam system because the different parts of the facade are assembled on site, while the interior windows are already assembled in the factory, so they are more like a unitized system. Okay, good observation already. So it's a multi-layered facade with different technologies behind in the making. And the question is, I think the frame of the glazing system can become a thermal bridge in summer. Can you more explain how we solve it? So
I'm not sure I understand the question.
Yeah.
Is this about the cavity itself, which is going to heat up? Or
No,
is it about the connection of the inner facade to the outer facade to take the loads?
Let me
When
just
I look at
see.
detail 1, I would assume
Chuang Nguyen. We don't have Chuang Nguyen. Oh, maybe no. I don't think we have him here. Maybe I assume that you have. This is a double facade. We have an interior insulating facade that covers the interior from the cavity of the double facade, and then we have a second layer on the outside. And I understand that he is referring to the cavities construction that arches out in order to hold the second layer on top.
That's what I understand as well.
And I think also it comes related a little bit maybe with the vanilla example that we have similar.
Okay. Yeah.
With this whole way that becomes, in that case, because it's a refurbishment, a little bit of the thermal bridge. But I think maybe in this case is a bit different. So I think it's meant to be like that.
Yeah.
But then he's right. It's a thermal bridge.
Yeah, but
so,
we take care of that. Usually, if you look at the details, there is a small plastic spacer that creates a thermal barrier.
This is Buenos Aires, so it's not going to be cold. It's actually, and that's why he's addressing summer. It's just delivering heat to the inside. So you may do this with a spacer as well, but the risk is less intensive.
What I would like to mention in this is what an even bigger problem is that you make sure that in summer the second layer is being able to open enough to get rid of the overheating of the cavity. Because especially in that climate, the double layer is most likely ruining your overall comfort in the summer if you're not able to open it enough to ventilate away the glasshouse effect you are creating within the cavity. So therefore, this is the bigger problem.
And I don't see any shading, which is also something which we saw in South America at some places. We have these facades where they think like, okay, we now make a double facade to solve everything. But if you then don't ventilate it and don't shade it, you actually create a glass house in front of the building, which heats up inside.
This building is 2016, 2019 erected. There's facade designers being mentioned and the architects. I can't blame them right now for misunderstanding the common trend of double facades that we've seen 20 years ago, where only people looked at the pictures that they're shared from Middle German double facades and built them everywhere in the world as a sort of a hype, doesn't understand what they're doing. I'm pretty sure they do what they know what they're doing here and may have options for that, because I can see there is on the picture there is a grid underneath, so I hope and assume there's ventilation openings at the bottom of the facade and also in the top, and maybe even at the sides to get rid of the overheating of the cavity entirely.
I copy your comment. Absolutely correct.
Yeah.
Right.
Next one. Oh, there was a second question?
No. This is a new one. This is actually, again, the tiny house.
Yeah, precisely. This is a window installed in one of our dormers. The windows are low cost, double glazed sliders and have performed quite well for the last 15 years. These windows typically have a nailing flange and a place in the opening after the house wrap air and water barrier. That flange is then taped to the wrap to create a continuous seal. This is a standard detail that you put the sealing around the facade connection element. Corrugated metal is used on the dormers because it is a low maintenance cladding and is hard to reach location. The same treatment is used for the other opening at grade, except that a trim board and clapboard is used for the siding. So the question here is, which is the facade system of this example? I can't tell. This is a very common Northern American
would we call this
system.
Ventilated? We wouldn't call that ventilated, wouldn't we? No.
No, it's in principle is a very typical residential system. This is what the standard contractors with a little pickup truck will do. It's a standard little, yeah. I don't know the facade system. Is it? Do they ask for product names or the system? This is a. Is it a facade cladding?
It's a handmade sandwich system, which is sealed outside and inside.
Yeah, it's balloon framing.
Name it balloon framing, and then it's covered at the outside with a cladding.
Yeah.
And same discussion as we had before. The cladding then may penetrates the sealant from the outside. And what he's now referring here to is that the window itself is brought in position and then duct taped around to create a sealant. That's how I would see this. And the question can be from whether the flashing seal only be applied along the top and side of the window. The bottom will receive no flashing type, so that any water may, if the water is in that level already, I wouldn't be happy.
No, precisely.
So I would actually expect that the aluminium profile itself is drained to the outside, and not trying to somehow have any water then flushing into this.
We have to be aware that this is residential buildings,
and windows,
there is precisely, and there is many variations across the different country. We see snow on the right hand side. The United States, in this case, it's quite big. This is Buffalo, New York, so they have an intensive winters. For instance, my reference is always this old house. It's a American DIY television series, and Mr. Silva explains various times how to apply the various layers properly. For the flushing and the windows, ceilings, so something like that, because this is often product specific. It already starts with the windows. In this case, we can already see some flanges attached to it, how they apply to. So they may have already applied some tricks in order to make the overall assembly foolproof or easier too. That also comes in handy with the right tapes and flushings. You already mentioned the corrugated metal. That is what we also have from Velux underneath in order to be wrapped around the neighboring roof tiles. So therefore, different to judge from a higher perspective as we have right now talking about systems. This easily and quickly becomes a talk about different products and product systems, which have to be careful, because within their system they have most likely thought it through well. If you come with a half knowledge, you may not apply it perfectly.
The red square I drew is, say, the base of the aluminum profile, which I understand. And then we see at the left side, we see these two U sections where the sliding window actually punches into. If you think this now not as a horizontal but a vertical section at the bottom part, well, I would expect that somewhere here there's a need for drainage, and there's maybe somewhere here a need for the drainage. And if this is really the case, I would be unhappy to not have this sealant here. Because the drainage actually needs to find its way out and not into my system. If it's in the system and then needs to drain out here, this is even more disaster.
So I would also see this. This is most likely a plastic window, and not an aluminium, and not an aluminium one. If it's a cheap,
well, you're right. Then it's plastic.
I would say then it's plastic. Then they may have not to deal so much with the thermal bridges, but of course then the
rain comes at the
precisely
condensation as well.
It is the detail here is systematic, while the product may have already dealt with certain points of the building physics, how they apply to it.
Yeah.
So therefore, be careful with that.
I would, yeah. I would, if you see it at the side and the top, I would not seal it at the bottom because of drainage.
Yeah, me too. But if you buy a specific product, they will advertise and they will also tell you exactly what they think, because then you are also able to follow their warranty and so on.
So one of the deeper messages between this discussion note Marcel and me are having on this are, if you don't know a system, it's hard to securely on all levels judge directly if the system has major failures for its climate or not.
Yeah.
Secondly, and that's then say the step back, judge it from your experience, gravity, humidity, temperature, say there's always these principal forces which are dealing with the detail, and the detail has to solve these forces. And if you don't understand why this detail solves it, then the next question before applying it to a construction would be talking to the one who's supplying it and ask them. And there you should also ask exactly the maybe stupid questions. Why do certain things work like they work, and how does this detail support the, say, physical needs?
Yeah. Especially building physics is very tricky here. We've talked to Ilford, the guys who make these semi-permeable water and moisture barriers. If you just mix the systems in and out and whatsoever, you might also be having a problem according to the different climate zones, that you don't have the openness of the one barrier in front and in between. So therefore, stick to the system if you choose a system as a product and then do exactly what they do. If you change as a single tape, it may already become a problem.
Yeah.
Tatjana, you wanted to say something. Body language was telling me you wanted to comment.
No. Okay. We have an extra question related with this, but
there comes the extra question.
This comment may not be to not be relevant to the assignment, but in the spirit of learning, we can point out that modern aluminium window frames that are double glazed typically involve a composite system of interlocking aluminium and synthetic nylon extrusions, where the nylon serves as thermal break insulator. The low cost frame detailed here is a thermal bridge. Totally right. That's what we already mentioned. Of course,
correct.
Totally correct.
That makes
aluminium,
me believe it's an aluminium window.
Yeah. So this becomes then a thermal barrier or a thermal bridge, and a modern one already have an insulator.
Well, when we start thinking about thermal, this being aluminium, Marcel, we may expect that some, say, moisture going to happen here. You see the dots?
Yeah.
And that may cause rotting for the studs.
Yeah.
Which may also be an interesting one when I think about it.
Yeah.
Okay. Side story. We go to the next.
Yeah.
That's still our last.
Oh, that was the last one.
Actually, perfectly with the time, because time is perfect. So you nailed it.
Perfect. Just a little anecdote. What Uli mentioned, condensate. We have seen facades coming off, or glass coming off from a post and beam facades with wooden mullions, due to the fact that the guys on the building side have used steel screws to clamp down the glass clamps into the wooden mullions, and they have actually been performed as a cold bridge. And within the wood, the condensation started in the warm inside mullion, and then closed into, they have started rusting, corroding over the years, and then at the very end, just the facade, when the wind comes up, pulls it off the facade. Everyone was wondering what happens because of a thermal bridge and condensation, that it starts rotting around the screw head. How to avoid it? Either choose first for a proven system and don't design this by yourself if you are in a questionable climate, and second, use stainless steel screws. That will already prevent thermal bridges by a lot, because stainless steel is not that conductive for heat.
And it doesn't corrode.
And it doesn't corrode, precisely.
In the cavity. Right.
Okay. Thank you very much, guys. And before we say bye, I also would like to say thank you very much for all the participants. We are very happy to see you. We already have more than 1,100 learners. So bravo for joining. They are from all the continents, basically, from 117 countries.
My goodness.
And we would really like to see in your assignments different ways of building and solving problems. And actually, we enjoy these webinars because we can reflect in these different ways of building and how to improve and how to also learn from that as well. So thank you very much.
Absolutely.
Yeah.
Don't forget that we are reading you and following your assignments as well. So that's why we have these as well to have like some feedback for you as well. So thank you.
Yeah, it was a pleasure. Also, the questions we got very deep. So we really see that you take this serious and that you are interested in the topic. Makes us very happy.
Yeah.
Great.
Good. To be continued. Thank you.
To be continued. Hope you still enjoy watching our videos as we did making them. Please also share some comments later on if you ask how you liked the course. Helps us to maybe already prepare the second season of it.
Exactly. And we will be posting this webinar online, so you can check it when you want as well later.
Perfect. So
thank you, Ulrich. Thank you, Marcel.
Bye.
Tatjana, thank you.
Thank you. Bye.
Bye.
A couple of thanks already here in the chat.
Yeah.
Nice. So.
Yeah. Mercy, I need to run for the next session.
No problem. Uli, have a nice day. Bye.